Hello, my people. How na day? How say na day they go well. Today, make we just look at eigenvalues and what eigenvector again. This time around, we want to run with 3 by 3 matrix. We just 3 by 3 matrix. So what we want done with today. Now, they say make we find the eigenvalues and eigenvector of the matrix. This you have your 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2. Now, person if you see this thing now, talk say, bros, where I go start from? And they say like tell me, am I cancel? Make work they reduce. No, be like that too. First of all, you start by writing your word formula. Your formula, we're going to be two formulas we're going to be making use of is this to get our eigenvector, and then each other one again. Determinant of the whole of this our a is equal to what? 0. Yeah, man. Wait, I talk now. Determinant of our a minus lambda minus 1 is equal to our what? 0. Not just a because. So we are going to be I engaging car. We go use this one. Get the eigen value. Let's do that. So the determinant of our a being representing the whole of that 3 by 3, 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2. Then we will subtract it from our eigenvector, which is going to be multiplying a 3 by 3 identity matrix. Identity matrix, remember, not only here they get 1. The other part is just what? 0. Now we want to find the determinant of this. Now, if we multiply this guy into this place, our 1 will then become what? Lambda. Okay. Now, from here, space no deal. Okay. Space no deal. Try. No, now shift this stuff small. Yeah, man. So, we'll subtract this stuff now using matrix and pattern. When we do that, we'll be having the determinant 2 minus lambda minus 1 minus 0. Now minus 1, we know that one. 0 minus 0, 0. I know that one. Minus 1 minus 0, minus 1. 2 minus lambda minus 1 minus 0. 0 minus 0. Minus 1 minus 0. 2 minus lambda. Okay. So this is what? A 3 by 3 matrix. A 3 by 3 matrix. And we know how to find a determinant now. You go add your signs here. There you go for the first one. Your 2 minus lambda, which is this one. Then every other thing in this other that's not in each row and each column. Okay. Now we have this times this, which is 2 minus lambda. 2 minus lambda minus this times this is what? 1. Then we then move over to the next one, minus 1. If you write 1, but it's still going to give us the sentence to write and minus 1. Okay, it's going to become plus now. This is minus 1 minus the minus 1, then multiply by everything we know there is roll and column. So this. Sure. Now this times this will be giving us minus 2 minus lambda. Sure. Minus 1 is multiplying this number here. It's going to give us this, right? And here. Now 0 times minus 1 will give us what? 0. So no need of us writing it. You can just close the brackets. If you still want, you can go on to write minus 0. But you know it will still cancel, it will still go off. Now we're not done though. One more matrix. We're having this one over here plus 0 multiplied by every other thing that is not in this row and column. But as you can see, no matter what you get from this place, as long as you're multiplying it by 0, that is definitely going off. It's meant to be this guy times this guy minus this guy times this guy. But since we're generally multiplying by 0, all of this is what? Going off. So our determinant is going to look more like this. Now I'm not going to get space, put my 0. This equal to 0. And over I can put that for front here. God. Okay. Yeah, man. So for us to, I go like we could just do small manipulation, small. Let us just say that 2 minus lambda is equal to what? B. That's one substitute. Because if I just substitute, we no go see some things. We got to see from another dimension. Understand? You guys understand though. So when we substitute that here, we're going to be having B brackets B times, and if you put another bracket, times B minus 1 minus times minus now plus, having plus 1 times minus B plus 1 times minus what? B. Solving further, you have B brackets B square minus 1 is going to be equal to, this is 1 times everything here is now going to be giving us minus what? B. All of these things is equals to 0. Don't get confused. Oh. 2 minus lambda, we place it with what? B. So in place to see 2 minus lambda, place it with B. This guy was replaced. This other one replaced. We will get our minus 1 there. Here, minus times minus is what? Plus. That's reason for this plus 1 here. Minus. This guy is what? B. Capital B is equal to what? 0. Now, I'm solving further. Your plus 1 times this one is going to be, you're going to be left with what? Minus what? B. So this is equal to what? 0. Now the reason why I initially wanted to substitute at first is for the purpose of me seeing this b that is here and this b that is here, meaning that we can actually factorize out b. When we do that, we'll be having b squared minus 1 minus 1. You understand what the reason for this minus 1? We factorized b out. B was common in the two of them. So we brought out this common factor out, which is this. I hope you see it. I hope you see it. I hope you see it. This stuff in the bracket can be any number. This stuff in the bracket can be any number or any alphabet. Yeah. In case if you're not seeing it well, this if you're to call this anything now, this one in the bracket, let's say you're going to be having b c minus b is equal to what? 0. B is here, B is here. We factor out. We have b c minus 1 is equal to 0. That's what we just did here. That's what we just did there. So I hope you're not confused. Confusion out. Okay, let's go. Now from here we can then say that our b is equal to what? 0, and our b square minus 1 in brackets. Actually, you can actually solve for this value, but still minus 1 is also equal to what? 0. Is also equal to what? 0. So from this thing we have gotten two equation. You know, this thing I just did here is your normal quadratic equation, the way you solve your polynomial. You can have something like x minus 1 in brackets and x minus 2, your quadratic equation. You say all this is equals to 0. They don't tell you that x minus 1 is equal to 0 and what? If you notice, what is in between them is a multiplication sign. The same thing here, multiplication sign. So we can say the whole of this is equal to this, and this is equal to also this. I'm obeying this quadratic rule normally used to use. Okay, now that only works for when it is 0. When this is 0, if it's not 0, it doesn't work. Now I'm substituting our values back again, and we are having 2 minus lambda is equal to what? 0. That is getting this guy back. Now the other one is going to be 2 minus lambda all square is equal to, sorry, not equal to yet, minus 1 is equal to what? 0. I just substituted back. No, this process that I took now, it wasn't compulsory. You can actually go further to open your bracket and do all those stuff, but it will take more time, and this is more like a shortcut. But after getting from here, maybe you don't even need to substitute for this. You can just continue solving the normal way you will solve. You will get the same answer that I'm going to get right now. Okay, now from this first one we can say that, remember, this one is from this one, this one is from this one. Now from this place we can then say that our lambda is equal to what? 2. So we have gotten our first lambda to be what? 2. So for this one we're going to be having, if we are to open this bracket, we have 4 minus 4 lambda plus lambda square minus 1 all in brackets minus another 1 is equal to what? 0. This is from the second one though. Remember, this is this, why this is this. We've gotten the first lambda, our first eigenvalue. Now from this place we can solve. Then we have that our lambda square minus 4 lambda, having 4 minus 1, we have what? We're having plus 3. All of this minus your lambda, minus your 1 is equal to what? 0. From here, minus 4 lambda plus, wait again. Okay, open brackets now. When you open brackets, you have this is equal to what? 0. Now 3 minus 1 will give us what? 2. So use your calculator, you can now get the other two quadratic equation. It's not going to be quadratic roots. So it's going to be 1 for the coefficient of this our first guy. The other one is going to be what? Minus 4. Remember, the arrangement is what you have to do before you start using this method. Then 2, you'll be having that your second lambda is what? 2 plus root 2, and your third and final lambda will be 2 minus root 2. You know that all these things are not compulsory like that, but you can actually use your almighty formula, your polynomials rules, many of them, to get this thing without calculator. But calculator just makes it fast. It still has, I don't know the disadvantage yet though, but I'm actually enjoying the use of the calculator for now. Okay. Now we have gotten our 3 eigenvalues. Remember, the number of row and column of your A determine the number of eigenvector you're going to be, eigenvalues you're going to be having. So this is a 3 by 3. So definitely our eigenvalue is going to be what? 3. So is our eigenvector. So we are going to be deriving each eigenvector for each of these eigenvalue. Yeah man. Just the cook soup. We just the pour ingredients. We never even start. So okay. Now our lambda 1 is equal to what? 2. That of our lambda 2 is 2 plus lambda 2, and then lambda 3 is what? 2 minus lambda 2. Okay, so this can go off, right? Remember, this is where I solved this for this this is supposed to be a polynomial equation. If I continue solving with them without substituting all those stuff, and to start require it will still be quick with calculator to give you your answer for direct, but just do whatever you want to do. Understand? It's mathematics. Many ways to kill a rat. Always. Okay. Now going for our words again vectors. I'm going to be using this formula now. So we have that our A being 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2, all multiplied by x y z is equal to Ask where is XYZ from? It is representing your X, so X is what for variables. For variables, you can use ABC as you take once. Some textbook normally used to use X1, X2, X3 as it pleases you. Understand? Any way that it pleases you. This is X, Y, and what? Z. Yeah, man. This is this. I hope you know. Okay. Now, from here, when our eigenvector is now what? 2, we'll be having 2 minus 1, 0, minus 1, 2, minus 1, 0, minus 1, 2. So the other time we start at xy. Here we are going to what? To z. The reason for this is also because of what? Our a is a 3 by 3. So we are going to be, if it is a 4 by 4, we'll be having x, y, z. Any alphabet, I feel add them omega. Something like that. Just something to represent the fourth one. So the dimension of your a determines the number of eigenvalue and eigenvector you're going to be having. So it determines the number of variables you're going to be having. Now, going on, this our 2. This our lambda is now going to be replaced by 2, and when we multiply through, we're going to be having 2x, 2y, 2z. Okay, I hope you guys grab. Okay, now using the normal equation form, we're going to be having, converting to the normal equation form, we're going to be having 2 times x plus minus 1 times, so plus times minus is minus, so we're going to be having minus 1 times y is going to be what? Y plus 0 times z is going to be what? 0. So all this will give us 2x minus 1 times x minus x, 2 times y plus 2y minus 1 times z minus z is equal to what? 2y. 0 times x is 0 minus 1 times y. We're going to be having minus y minus 2 times z. We're going to be having 2z is equal to what? 2z. Hey, yeah man. Okay, so at least from here we can do something. We can say that when this crosses over, it becomes minus. So we are going to be having that y is, and this guy crosses over, when we have y is equal to what? 0. Wow, is that so? Y is equal to what? 0. Okay. If that is so, we can actually substitute that here, and we have that 2z is equal to what? 2z. Definitely this will tell us that our what? Our z is equal to our what? Our z. Okay, our z is equal to our z, our y is equals to 0. Now what will our x be? Only one way to find out. Okay, now This one might be a bit long. Oh. This one might be a bit long. Okay, let's go. No fear, oh. So I don't talk long like this. Man, don't skip. So minus x 0, replacing this our y with 0. 0 times 2 is definitely going to give us 0. This guy is off. We're going to do this minus z, the same thing here, is equal to what? 0. Sure. So we can then express this to be that our minus, or we can say our x, if the x is to move over to this side, is equals to what? Minus z. So we can now go further to say that our x1 is going to be what? For our x, we have it be what? Minus z. But I would like to represent everything in terms of what? In terms of x. In terms of x. If that's been the case, I'll have to rewrite this. Now making z sort of formula from this place. If I'm to make z sort of formula from this place, I'm going to be having, that's our z crossing over. I'm going to be having z is equal to what? Minus x. Okay, so I want to express everything in terms of x. So my x will still be my what? My x. Our y is going to be what? 0 for what we got here. But our z is now going to be what? Minus x. Multiplying by 1, we'll be having 1, 0, minus 1. Now it's not left for us to normalize it. When we do that, we will have our final answer for our x, for our x1 is now going to be what? Hope you understand the reason why I omitted the 0. 0 square is still 0, so there's no need of adding it here. So this is going to give us 1 root 2 1 0 minus 1. So we have just gotten for one eigenvector. Kai, my neck don't depend me. Oh, okay. So we have gotten for one eigenvector. Just one of it. So I'll be. So let's shift these guys a bit forward. Okay, so that's our x1. This guy. Now let us try for this other guy. The whole of this is going off. Oh, it's going off. All of this is going off. Oh, it's going off. The whole of this is going off. Oh, it's going off. So this time around our lambda is now what? Plus root 2. Hey, don't fear. So this one we get square root. We fit solve am. It's solvable. So 2 plus root 2 all multiply by your what? X 2 plus 2, plus root 2 all multiply by what? Y 2 plus root 2 all multiply by what? Z. Okay, hope you understood what we did. We're still using this formula to get our distance. our eigenvector. Now we're just substituting our lambda with this guy, and we're having this. Now we can now simplify. We're going to be having that 2x minus y, 0 times 1 is 0, so it's going to be giving us 2 plus square root of 2 all multiplied by what? X. And the next one, minus x plus 2y minus z, that's minus 1 times z, is going to give you 2 plus root 2y. The next one, this one is going to be giving us 0, minus y plus 2 times this is 2z. Okay, all of this is going to be giving us 2 plus root 2z. Yaman, 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 yaman. Okay, okay, okay. I beg you. Your boy don't dey tire already. I want to give up. Oh, 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 oh. Never give up. Never give up. Never give up. Never give up. Okay. There you go. If you haven't subscribed to the channel, please do so. Like, comment, understand? And pay attention. Just pay attention to what we're doing now. Pay attention. Pay attention. Okay. So I want to take everything now, like terms today. Want to separate them, like terms one side, unlike terms the other side, how you take it down. So let's say this one will be easier. Let's move this guy over here and then keep our minus y here. Abi, would that one be preferable, or y coming over here? Let's do y coming over here, this guy coming over here. Because of space, this is equation 1 coming here. This is where I'm continuing it from. This is where I'm continuing my equation 1 from. Now equation 1 continuation, from here we're to simplify it, we'll be having 2x minus, okay, and so multiply, you have no need for that, 2 plus root 2x is equal to what? Y. Now you can also factor out your x, so you're left with 2 minus 2 root 2. All of this is multiplied by your what? X is equal to what? Y. Now you can go on with your calculator. Now type in this. You have 2 minus bracket open 2 plus root 2 bracket close. Why is it giving me this answer? Why is it giving me this answer? I mean yes. Okay. So our answer is what? From here we have that our answer is minus root 2 of x is equal to what? Y. So what this means is that in place you see y, replace it with this guy, Jehovah. Okay. So it will permit me to go up here to our equation 1 and still rewrite it to be in this form. Minus root 2 is equal to what? Y. Okay. Okay. Now, focusing on the third one. The third one, which is this guy. I think we have gotten something for y. You can now easily substitute here. So we're going to be having minus in brackets minus root 2 representing the y plus, I'm solving from here, the third equation. Now, this guy going over here, we're going to be having 2 plus root 2 z minus 2z. Now, this guy can be rewritten as minus times minus is plus. We're left with root 2x. Okay, now over to this guy, we're going to be having 2 plus root 2 minus 2, yeah man, or z. We just factored out z so that this likeness can do what? Add, can subtract themselves. So when we do that, when we calculate, we can impute what this is. We're going to be having 2. I think just going to get, we're not be having just root 2 there, but to be 100% sure, let me just do that thing where they their mind. Then I know go there for understand for that aspect. Understand corrected. Understand correct. Understand forget. And this is going to be giving us root 2 what? Z. Now, if we divide both sides by this, if we divide both sides by that, we're going to be having that what? We're going to be having that what? Z, on the other hand, is going to be what? Equal to what? X. Dividing both sides by what? Root 2. Root 2. This guy goes off, this guy goes off. Remember, it was this guy that gave us this guy. So this guy goes off, that guy goes off, and we're left with what? Z is equals to what? X. Space. What is even consuming space here, sef? There's some unused space I'm not even making use of. Okay. So we have gotten this. Now, what this means is that if we substitute what we have gotten from these two into this place, it should give us an answer. I know verse. I will write this one for top, just up here. So from the second equation, which is this one, if we substitute for these two values into this, we have that your x is equal to what? X. I wanted to do that, but I had a change of mind. It's time consuming. We're wasting a lot of time in this thing. So we have that our x2 is equal to x our y being what? X minus x root 2, and our z being what? X. So substituting our 1, we'll be having 1 minus root 2 1. You still have to normalize that. At this point, something has to go. Something is leaving. I guess has to be the question. Let's get this guy off. Joy of rivers. This is what I got. And when you normalize it, you have that your x2 is going to be 1 over square root of 1 square plus minus root 2 or squared plus 1 squared, all multiplied by your matrix 1 minus root 2 1. Okay, now from there we have that our x2 is going to be, solving this calculator, this guy will give you 2. This is 1 plus 2 plus 1, which is 4. Square root of 4 is 2. So we'll be having 1 over 2 of 1 root 2 and 1. Finally, hey, still remember one more. Tag. Okay. We can do this. This is a small thing. A small thing. A small matter. A small matter. This is our food we must finish. Understand? We can't finish this stuff. No. Now around is not going to be what? Now solving with this other guy. When I go green, I just do small adjustments. Ta-da! Okay. We have succeeded in shrinking some things, and the art of shrinking is called minimizing. Okay. So we have gotten for the first eigenvector, second eigenvector. Now we're now moving over to the last one, which is our that of our lambda 3. Now, when we sub in our, that's to replace this guy with this guy, we have 2 minus lambda 2 all multiplied by what? X 2 lambda 2 multiplied by y 2 lambda root 2. Just say lambda 2 minus root 2 multiplied by z. Now converting it to a normal equation form, we'll be having 2x minus y. That's 2 times x is this, minus 1 times this. We have done this enough times, so I guess by now you should grab how we are getting this. 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 Okay, okay. Now, we have done majority of the work. Now it's just simplifying, expressing one term in term of the other. We'll be doing this for the first one. For the first one, we have that 2x, this guy coming over, minus 2 minus root 2x is equal to what? Y. Understand? Now, the like term say you can just factor out your x, and you're left with 2 minus root 2 x is equal to what? Y. Solving this, you have what? She does root 2 minus root 2. 2 minus bracket open 2 minus root 2 and bracket close. We're left with what? Root 2 of x is equal to what? Y. So whenever you see y, you replace it with what? Root 2. So you can come over here and say that this gives us that what? Y is equal to x root 2. These two things are the same. I brought my x in front. This is why I use put bracket whenever it's at the back, so that you will not think that the square root is also covering the x. The x is not covered by the square root. So a better representation is this. Now we have solved for the for the y. Just do for the third one. For the third one, since we have gotten the value of y, we're going to be substituting it there. We're going to be having minus x root 2 plus 2. Okay, everything that is not y, everything that is z should go over to this side. We'll be having is equal to 2 minus root 2 z minus 2z. You grab, right? Okay, now minus x root 2 is equal to 2 minus root 2 minus 2 times your z. Solving for this guy, I think you're left with okay, so you're left with y minus root 2 times what? Z. We can also write this guy to be also minus root x, no, minus root 2 and your x. These two are the same thing. They are the same thing. You grab. Okay, now dividing both sides now by root 2 will then be, and by minus root 2 we then have that what? Our x is equal to what? Z, or better still, our z is equal to our what? X. Yeah, man, this is what we got for the what? The third one. So from here we have that what? Z is equal to what? X. So all this y square root don't fear us like this, but it's solvable. It's turned out it was solvable, all this y. but we doubted ourselves. Now for this guy, I didn't solve it in the second example. I'm solving it now. Okay. Now substituting our values that we have gotten for both x and y. So from your 2, you have that minus x plus, this is 2x root 2 minus x is equal to 2 root Yama. Okay. So this guy will give us minus 2x plus 2x root 2. Okay. All of this is equal to, now where this man, opening the brackets, this times this will be having 2x root 2. This guy, you're going to be having x bracket 2. Why is it x bracket 2? Root 2 times root 2 will give you what? 2. Okay, so this, that. 2x, 2x is there. We can have 2x out. And we have minus 1 plus root 2, which is equals to, this can be written as 2x. 2x out again, we'll be having root 2 minus 1. Those two things are the same. So dividing both sides by this, these two are off. We are left with 2x and 2x. Dividing both sides by 2, left with x is equal to what? X. I knew this as well. I don't want to solve it. It's just, I don't know how to say it. It was logically correct all this while, but I just needed to prove, wasting my time. In the exam, I won't waste this kind of time. Mainly I've gotten for my y and gotten for my z. Straight away, my x is equal to my x. So x3 is now going to be giving us what? X, y, z. This is something, we're replacing our value, so we're going to be having x, our y is x root 2, and our z is x. Now, and then multiply, I'm assuming that our x is 1, we'll be having 1 root 2 and 1. Normalizing this, we're going to be having 1 over square root of 1 square plus root 2 square plus 1 square. All of this multiplied by our 1 root 2 and 1. So finally we have that our x3 is going to give us what? 1 over 2, 1 root 2, 1. Yeah, man. Okay. So finally we got the 3 normalized eigenvectors, 3 eigenvalues, 3 life, 3 star, 3u, 3h. Wow. Or something. But I hope you walked in this journey of life with me. I hope it wasn't boring. See you in the next video. Goodbye. No, calm down. Ish. Subscribe, oh, subscribe. So, don't leave here if you're not subscribed. Subscribe, oh. Now, bye bye.